Yeah. So I don't think I'm gonna implement the pings and the pongs unless I need to. But I'm not gonna do that. We're definitely gonna need to handle this case, but I don't think I need to even handle this case because I don't think I'm gonna be sending that. I'm never gonna be sending that much data, so I may just not even handle this case altogether. Um, like this won't even work because my buffer size is too small anyway. Um, so that'd be a lot of information. So the only question is, should I handle the case where um, we get two messages separated? I'll have to check. Once I'm sending data back and forth, see what happens, and if it does break it up, then I'll handle it. If it's not, I'm not gonna handle it. I'm not gonna have this handle situations that I don't need to worry about. And I'm just sending small packets anyway, so that'll be that. And if I need to do anything else, I'll update that as needed. So, okay, let's send data back now. So I think I can kind of infer what I need to do from that. Yeah, I think I could just figure out what to do from that. So we have on socket message. Now I want to have a method. Send socket message. And it takes in it takes a socket, send socket message. So we'll just do this when we receive a message, and then just as a test, we'll send socket message. The message will be Mr. Babin. And that's from this socket. Okay. Yep. So how do we do this? So it's the same thing but in reverse. So it's basically this but in reverse. So I'll open up the Wikipedia. Oh, Nginx has support for WebSockets. Acting as a reverse proxy or load balancer. Okay. Fenrir is going to be for what I need it to do. It's the foundation of a WebSocket server, but it's not going to do everything. It's only going to do what I need it to do, basically. I'm not going to implement stuff that I don't need to do. I don't need to worry about. So basically, we need to construct this thing here. So how am I going to do this? We're reading from the buffer, so I'm tempted to just use that same buffer to write a message out. Yeah, I'm tempted to just use that buffer to write something out. So I'm actually going to do this here. I'm going to yank this, paste it. So we're going to do all of this, but in reverse. So we're just going to override the buffer, but I have to make sure to clear stuff in the buffer that we don't need. I think I'm just going to use... Yeah, I'm just going to use the buffer. Okay, first let's start the fin bit. So the fin bit, instead of doing this, I'll actually be writing it to the buffer. Right, so like here, I'm gonna be saying buffer 0 is equal to, so the first byte is going to be all zeros except for the opcode and the fin. So the fin we're gonna have set to 0. Or no, the fin will be 1, right? Meaning that it's the fin will be 1, meaning that it's the last message. So we want that bit to be 1. We're gonna have 0, 0, and then whatever we want the opcode to be. So what's that? Just want to make sure that that's right. If it's 0, right. Okay. So we're gonna have that bit set 0, 0, 0, and then an opcode we're gonna write in. So 0, 0, 0, 0. That's 80 in hex. Right, which is the same thing I have here. That's that one bit I was extracting the fin. Now I'm setting the fin. So I'm setting it to this, so that will set that bit. Those are all zeros, and then that's all 0. And then we're gonna OR that with the opcode. Now the opcode, what is the opcode? The opcode is going to be, so 0 is continuation, 1 is for text, 2 is for binary, and then there's control codes. So for now I'm just gonna do text, so the opcode's gonna be 1. Could say it doesn't really matter, but so we have the opcode. So I could send message. We're doing it as a string, so the opcode is 1. Write that into the buffer. Right. Take this, OR it with the opcode, and we've now got that segment in there. No. Yeah, that's right. We got that. Now, mask, I think it said the server shouldn't be passing in a mask. So the mask should be 0. And then we have the payload length. So this is the only tricky part now. Is the determining this payload length. So what we have to do is we're going to have to check if the message is, so there's two cases. So if the message dot size is less than or equal to 125, right? If the size is less than or equal to 25, then we're good. We're just going to write it in the payload length. So let's do that. So this is the second byte. Yep. So the second byte is going to be equal to, well, the mask bit is, we're always going to have it as 0, right? And then the next 7 bits are the payload length. So what is the payload length? It's less than or equal to 125, so we can just use the message size. So yeah, if it's less than or equal to 125, that bit's going to be 0 anyway. So we can just say static cast to a uint 8t the message size, and that's that bit set. So that's the first byte, that's the second byte. The extended payload won't be in there. There will be no extended payload. The masking key, we're not going to have a masking key. So then we just go right into the payload data. Right? We just go right into the payload data. Now, if the message size is not less than or equal to 125, I'm just going to assume, I don't think we're going to have it go, yeah, I think that's just going to be crazy. This is a 16-bit integer. I mean, a 16-bit integer. I'm not going to be sending messages that are 65,000 characters long, so I'm not going to worry about that. So if the size is not this, then what we do is buffer 1 is going to be, the mask bit is going to be 0. The payload length is just going to be 126. We're going to say 126. So this byte is just going to have the value 126 in it. That's it. Simple as that. That's right, 126. But there will be an extended payload. So now we need to write the extended payload is the extended payload length. The extended payload is going to be 2 bytes, right? 16 bits. It's going to be 2 bytes. So it's going to be buffer 2 is going to be the message size, right? The message size bit shifted to the right by 8, and then buffer 3 is the message size, and you only want to take the first byte, right? Yeah, okay, so opcode is 1. We do that, word with the opcode. right? So it's that bit shifted to the right by 8, and then it will cast it down to an unsigned int, right? 8, and then that we just extract the first byte. I think that's right. And then the other case I'm not going to deal with because I'm never sending messages that are beyond 65,500 characters. So that should be that. We have that. Now it's just the payload. We don't have a masking key. Now we have the payload. So we don't have this. So it's actually fairly straightforward. The payload data now. Well, we just need to write this message. We need to know what index we're at now. So we're going to still need a buffer index. So we're going to be at index 2. Here the buffer index is going to be 4. So we're going to say buffer. We're just going to read the bytes into the buffer. Now for that, we could just do a mem copy. First I'm going to do it the hard way, then I'm going to see if I can just mem copy it. Yeah. Well, let's try the mem copy. So mem copy, I believe it's the destination, so we're going to buffer. So buffer at the buffer index. Right, so we're gonna write to that location. We're gonna write from message.cstring. Right. And then how many bytes? It's the message size. That's how many bytes. So we copy that into the we've copied that into the buffer. Now we just need to write the buffer. Yeah, I think I deleted the send code, which was a bad. No, I didn't, because I write response. So I still have this code. So we then say send the socket. We need a pointer to the. This is a pointer, so this is just buffer. And then here's the tricky thing, is how many bytes are we writing? Well, we know buffer index is where we started writing, and then we did message size bytes of after that. So I think it's buffer index plus message.size bytes. I don't know what this last 0 is for. If it's a socket error, failed to send socket. Failed to send socket message. So we do want to. Oh, nice! I can just jump to it there. That's pretty good. So send socket message. So At this point, I can just return that, right? But I think that's right. Right. The buffer index, and if you just have one byte that you added, because if the buffer index is at 1, we read 1 byte, then that's at 2. So yeah, the buffer index is 1, plus 1 is 2. So you actually have to do plus 1, I think. I think you need to do plus 1. So Fenrir is up and running. Oh, what happened to my server? Shit. Did I close that? Yeah. I closed oh no, not test. Yeah, see it tried to do this and there's some kind of weird thing. No, it's the actual file. Here we go. There's Fenrir. Okay, I'll shut this down and restart it. Connected to server. Boom! Connected to server. Message received. Mr. Babin. We are now sending a message back, so that's good to go. Hello there. Okay. Now let's do a little something else here. When we get the message back, I'm gonna say socket.send. Yes. So it should just continue to send data nonstop. The server must not mask any frames that it sends to the client. Why am I masking frames? So we connect, we receive the handshake. They then send hello there. We send the message back, Mr. Babin. It then sends yes. We get the yes. We then send the data back. Now it received. I think this 32 is maybe this client asking the server to close. Let's not ask any frame mask. We're not masking anything. So we sent the socket message. We sent the socket message out and we return, right? And we return true. So we come all the way over. Who calls this guy? We come all the way over here. And then we just loop. And then we wait to receive some more data from the buffer. Let's add a bit more data. Hello there. And then we sent out 12 bytes. Bytes received 12. Yes. Why is it okay, okay. So 12, we send out the same message, byte sent 12, and then I think it's sending us back like an error or something. So we never get the Monsieur Babin message again. And I don't know why. The masking bit is set. That's the only reason that this could happen, I think, is if the masking bit is set to 1. The server must not mask any frames. Okay, so let's... Oh, no, there's no masking, right? I don't have to do masking. There is no masking. So I don't have to worry about that. So that's not the problem. So we connect to the server and then the message... We connect to the server and then it sends us a message, hello there. And then we respond back with Monsieur Babin. It then sends us another message. Yes. Okay. And then we want to send back another message. So we send back another message. I'm right about memcopy, destination source, and then the size. Yeah. Okay. Like that mask bit would be in the payload length, but well, let's... So the mask bit is 0, right? And then you have 1001, which is the payload size. Which is 9, right? Yeah, that's right. I don't get it. That's the mask bit, and the mask bit there is 0. And then starting from the second one, that's your message, right? So close. We got the handshake. We can receive data. We can send data. I'm not going to do the ping and the pong stuff. I'm not going to worry about large messages. And I'm not going to worry about concatenated messages. I don't think that's ever going to happen. So once we have this, I just have to handle multiple socket connections at a time. And then we're almost there. Yeah, I don't know what's going on. Yeah, I don't know what's going on. Do I have to be explicit? I thought this worked. Do I have to say? I don't have to do that, do I? Bytes received 32. The message is WebSocket protocol error. So it's telling us there's something wrong, right? We're getting a WebSocket protocol error. When I call the send function here, am I using that? Yeah. Oh, those are flags. Okay. What's strange is that the length here is an int, so you can't even send 64 bits worth of data. Right? I don't think I have to do this. This worries me, is that if things aren't shutting down properly or something, and so I have to restart the whole thing. There's still a lot of problems. WebSocket protocol error, and it's complaining. I'm wondering if what if I send the exact same message? Is it something to do with the buffer? That's the thing, like the socket's already closed, so I don't get why I can't connect again until I do that. A server must not mask any frames that it sends to the client. I don't think the networking will show any of this communication. No, it won't. This was the initial handshake. But that's it. This is really weird. This is bizarre. Is there anything that I missed? Well, it's possible, I guess, that the message is fragmented. I don't think so. A control frame, close frame response to the first peer, then close the connection. Holy fuck. The close frame contains an opcode of 8. The close frame may contain a body, the application data portion of the frame that indicates a reason for closing, such as an endpoint shutting down, an endpoint having received a frame too large, or an endpoint having received a frame that does not conform to the format expected by the endpoint. If there is a body, the first 2 bytes of the body must be a 2-byte unsigned integer in network byte order, representing a status code with value code defined in section 7.4. Coded data with reason. This data is not necessarily human readable, but may be useful for debugging or passing information. So if we get this, it's saying that it's closing the connection. Okay. Pings have an opcode of 9 and pongs have an opcode of A. I don't get why it works. Okay, let's confirm what's happening here, because so I don't know why I have to refresh this and then connect. So that's something on the front end side. So the first data we're sending back. Okay, so well, I really don't get this. I think it's sending the identical buffer or the same exact message. Like it is. It's sending the same exact message back. So how come the first time it sends a message back, it's successful, but then the second time it sends a message back, it's complaining about something? I'm gonna try something else now. I'm gonna have it send back 2 messages. So I'm gonna have it um, so we get the till message. So it has nothing to do with the client sending the message back. We send that message out, and then we send another message out. Um, so we send the first message out, it receives it. Then we send another message out, and that has the problem. A server must not mask any frames that it sends to the client. So what I'd like to see here is, what does that packet look like? Because it should be identical. Apart from the message here, but it should be the same. I think it's because when I close this, it doesn't close the socket connection or something like that. But I thought when you close an application, it closes all socket references and everything like that. So, I don't know. Like, this worries me because, like, what the fuck is this? Like what is this? Um, yeah, that's the handshake never happening, and it's like, why? And now it works. It's like, why does that happen? I don't know. I really don't know. Oh, after sending the second message, I got a server must not mask any frames. Interesting. can't be. Oh, that could be. Am I sending too many bytes? That could be it. So okay, so let's see how many bytes I should be sending. Let's confirm this. Yeah, like what the fuck is this? I can't connect. I get a 478, which is, I don't know what that is. I think that's the handshake. And then I send the handshake back and it ignores it. That kind of stuff is like, I don't know what's going on there. Is it because I'm not closing the sockets or something like that? Or is it something on the front end that's not happening? That worries me because that's going to be a problem. So what do we have here? Well, we can look at the buffer and see. So the buffer has this and then Monsieur Babin question mark, which is 11 bytes. We're telling it to read. Now the message size is 9 plus 1 is 10. There you go. That's the problem. You don't do plus 1. Right? It's the index is where you're at. So let's say you're at index 1. So that means you already have 2 bytes. Plus the message size. Let's say the message size is no. So you're at 1. You only have, that's the next, right. That was the mistake. That was the mistake. There you go. That was the mistake. What if I try to disconnect and reconnect? Oh, okay. Yeah, and we're getting the messages. So now we have the handshake working. We can receive data and we can send data. Again, I'm going to make this kind of specialized for my own needs. But because I'm going to make it available on GitHub, if anyone wants to use it, it's kind of a foundation of how you would have a WebSocket server working, and whoever wants to modify that can do that. But I'm not going to make this a general WebSocket server. I'm going to make it very specific to how I'm going to use it. So, for example, the data I'm going to be sending is either going to be text or binary. It's going to be just one of those. Okay, so that's that. Handshake, sending and receiving data. Another thing is multiple sockets. So, well, let's try this now. If I shut this down and then I restart the server, yeah, we're all good. We're all good. Socket closed. Okay, so so that's good. Now, so we connect. Let's start breaking this out into its proper thing. So, this endpoint stuff, I'm gonna remove. I think I'm gonna completely get rid of that. I don't think I'm ever gonna need to write my own web server, HTTP server. Well, maybe I would. That's the thing. I don't know. Maybe I would. code will be there. I want it. Path and then an endpoint. Yeah, I might move this code somewhere else because in case I ever do want to write my own HTTP server. I would need that. I'm just thinking about what I should do here. Well, so for sure, we're gonna have Fenrir. Yep. What's weird is if I copy that and then I go to I paste it. Oh, it does work. Okay. So there won't be a main method. Not sure how the library is going to work. So listen. Fenrir, listen. Listen, and then listen, the port, and then I think port the path. So listen, the port, and the path that the socket server is listening on. I don't know if I want to keep all the HTTP stuff. Yeah, I don't know. Maybe I will, maybe I won't. Yeah, maybe I'll just keep that in there. The listen, the port, and then the path. So still have the code in the main file. So yeah, we don't need a list of endpoints. We don't need that. Don't need to specify this. Don't need to specify this. And don't need to specify this. So we don't need any of that. We're not gonna have the port here. We got the buffer size. I think the buffer size should probably be, I think it should be double that at least. Maybe not. I don't know. I think the buffer is going to be fairly big. I think the buffer size should be 4096. I'm going to make a pretty big buffer size. 4096. So HTTP request. We don't. Yeah, I don't need any of this. It's very specific. So yeah, I'm not gonna include any of this. I just don't need that. Right. And I'll just move. This is one thing I wish we could do is I wish I could. Maybe I can do that, and it's just I need to rebind my key. Yeah. So another thing is a lot of these should be static, so that you don't get access to them outside of here, outside of this header file. Okay. So we have this guy here. So we say listen, the port, and the path, and that I think that's basically it. You just say listen, and then that's it. But I would need to specify the callback functions. So so we initialize WinSock, we create our socket that we're listening on. The port is there, so we need to convert the port to a string. Yeah. So I think we need to do oh right, there's just the toString method, and it gives you that. Get address info. What does that actually mean? STD toString port. I'm assuming that's what it's going to need. So we then create the socket that we're listening on, bind that socket, and now we start listening. So yeah, the socket actually starts listening. And then we have to start this while loop where we're actually so this while loop where we're actually come in, we accept a connection, so we just wait for a new connection to come in, and when a new connection comes in, so here's the problem is I need to have multiple connections. I need to accept multiple connections at the same time. So yeah, I might have to get into multi-threading here. Accept the connection and then start sending and receiving data. So we wait to receive the data. If we already have a handshake, if we don't have a handshake, then on socket handshake, so okay, on socket handshake, sure. On socket handshake, index, read a line from the buffer. So we extract the method, the path, and the version, right? I guess I'll leave that as it is. But then here, okay, this doesn't need to be done. Parse header line. No, we actually do need this. We actually do need all of this, and I deleted all that. Well, no, we actually don't need all. Like the body, I don't care about the body, right? I don't actually read the body. I don't do anything with it. And then I'm not gonna find the endpoints. I mean, there's only one endpoint. Why does it do that if I do it like this? Extract request parameters. I'm not going to check for request parameters, so I don't actually need that. Find endpoint by path. Again, I don't need to do that. If the endpoint is not null, otherwise the endpoint's not found. Don't need to do that. Just don't need to do a lot of this stuff. Read line from buffer, parse request line. That gives us the method, the path, and the version. And then parse the header lines. So read all the headers. We do need to do that. There's no endpoint that's going to do this. And then write response. There's only one response that will respond with this kind of data. So I would instead just say delete that, and then paste it. The response in the socket, just get rid of that. Just get rid of that. We do this to get the response. Yeah, I don't think we do that. So we just say the data is this. Okay, you could say Well, there's a problem again because this is the actual handshake, right? I want to yank 11 lines down, go back here. So we do this, extract this information, which we do need, and then check, instead of has header value, okay. So, just handshake. If we don't visit, then we set the status code to 400. Else response status code 101, right? And the message is, we have that here, right? The message is switching protocols. So if we don't have these headers, then the status code is 400. So it's 400 or it's 101 and then switching protocols. And if it's 101 and switching protocols, we also want to add this, where we're gonna hash this, and so we have that. So if the status code is 400, we don't do any of this stuff. It's just gonna be 400 and then that, right? So either way, we're gonna do this. HTTP, we're gonna have the status code, right? We're gonna have the status code, and then the message, which might be empty or that. Okay, so this is there either way, and then we add this either way, and then we write this data either way. So yeah, like the headers, if things work out, then we want to set our own headers. So this guy, and then accept, and we base64 encode the hash. So go through the headers and then do that if there are headers. I think this is fine. I think what we could do is status code, status message, and then maybe we put in just don't know if we still need the request. And by the way, that's gone now. I got rid of that. Fuck. So yeah, I think I just kind of want to this could just be the request headers, right? Actually, no, let's just do this here. So we just pass the request headers. So request headers, we have request headers. We come in here and then as header value, request headers. Yank that and paste it there. Nope. Yeah. As header, request headers. As header value. So I think that'll have to change a bit. So, okay, on socket handshake, we're grabbing what we need. We do this, determine what we need there, and then we have this. So, okay. Read line from buffer. Okay. Parse request line. That's fine. Parse header line. Okay, that's fine. Find endpoint by path. So, like delete that. Split path into elements. I just realized I deleted. Oh fuck, I deleted that. How do I know what the path is now? Shit. Find endpoint by path, so we split the path into elements. I'm not gonna do that. So find endpoint, where's the path coming from? Yes, I know, but where's the path actually coming from? Extract request params from the path. Where is the path? Oh, we get it here. Right, okay. Where are my buffers? Okay. So split path into elements. I don't need this. Extract request params. I don't need this either. That's the thing. I'm not going to keep code I don't need. Has header. Instead of taking in a request, so has header, right? Has header value. Oh, I have to change this. Okay, has header values. We have the SHA stuff. We have base 64 encoding. Wow. Here's the handshake code that we no longer need. Delete 13 down. And then we have on socket message. So this is where we receive a message, and then we have that. Okay, so parse request line. I don't think I do that anymore. Parse header line. Oh no, yeah. Parse the request line, then parse the header line. Find endpoint by path. I don't need that. Split path into elements. Extract request parameters. Handshake. So it has header value. It starts me here. Right, response, we don't need that. SHA, circular shift, base 64. Okay, that's a lot better now, I think. Okay. Now, a lot of these can be made static, right? Okay, so let's see how this this is going now. So why is going on with that? Okay, so I'm gonna include this project. Now, main still has a lot of code I've already written for HTTP stuff that I don't really want to lose. So I might keep that in a folder in case I need this another time. So, yeah, what I'll do is I'm just gonna make a copy of this for now. In case I need that later. So what I'll do now in here is you don't need any of this stuff, right? Shouldn't need any of this stuff. You should be able to just include Fenrir, right? And then so in the main, I should be able to just say listen. Port is 8472, and the path is test. Right. Now let's see if I can read line from buffer. So read line from buffer, that's there on socket handshake. Right, because you include it, so there's no way to not have it in there. So include Fenrir, and then we say, listen. I may want to do like Fenrir listen, or just the name of the method. I think if I would do that, I would do this. I think I'm gonna do that. So listen on 8472, and then we have this. What are the issues? Right. So listen should be a bool. Actually, I can just, I don't need to jump, right? I don't need to jump. What just happened? Okay. So if there's a problem there, false. I think listen would actually start a new thread, and it would listen on that thread for requests, and every time it gets a new connection, it spawns another thread. And at the end of your application, you just say Fenrir free. Uh, but okay, here's an example of that. It's actually request headers. Otherwise, that wouldn't work. So now we have our main application using Fenrir, and it's just as simple as that. Just listen on this port. This is the path. Yes, it's gonna be port 80. It's gonna be hitting the Nginx server, and Nginx will then forward forward it to this guy's port, whichever port he's listening on. And well, yeah, I don't think you need a path because it will forward it to this guy's port. So I don't think I need a path actually. So yeah, I don't think I need a path. Just listen on a port. Previous. Actually, no. If we go to this guy, let's just get rid of that. No path. Okay, so let's see how many things I fucked up here. Client connection established. Bytes received 474. Client has closed the connection. Oh, but now it worked out fine. Let's shut down the server. Hey. Everything's working good. Connected to server. Message received. And then it sent out hello there. Okay, so we now have Fenrir, right? So this is how we use it. I'm gonna want to know when a client connects. When we get a socket connection, I want to know. I want to know when we get a socket connection. I want to know when a socket disconnects. I want to know if there's an error with the socket, and I want to know when I get a message. I think. Yeah. Okay, so so listen on that port. It's not needed anyway because yeah, it's actually pretty short this. But this is basically what I want to be able to do. So yeah, this is basically what I want to be able to do. So so listen on this port. So we have on connection. So this is when a new connection is made. So I need to be able to handle when a new connection is made. Initialize stuff. Yeah. So on connection. So we need to be able to specify when a connection occurs. So this is when a socket makes a connection. And then so when we receive a message, we need to be able to handle that. And then that's it. So we don't have a disconnect callback. I thought I had a disconnect callback. If there is a handshake, then I think we're going to get a packet received. Right. Okay. So we set on error. So we need to get on message. So on a socket connection, on a socket error, on a socket message, and on a socket disconnect. So when a socket has disconnected, what do we do? When there's an error that we get on a particular socket, what do we do? Yeah, and that's it. So that's what I'm going to want to have here, basically, is specifying that. So I think I'm going to do this. I think I'm going to have everything like that. In the Fenrir namespace. Did that fuck stuff up? Okay. So Fenrir listen on this port, but I'm also going to want to specify callbacks. So I'm going to want to I need those 4 ones: connection, message, error, disconnect. And I need to be able to handle. So I would say we just do so Fenrir, so on socket connection, on socket connect, on socket connect, right? And then that'll be a pointer, and then on socket message, that'll be another pointer to a function, and then on socket error, and on socket disconnect. Right? So you you just set your callback methods. Yeah, maybe we don't even need to do that. Maybe we don't even do that. Maybe we just say Fenrir init, and then we'll pass in our callbacks here, right? Maybe that's simpler, right? So init, pass in our callbacks, and then listen on this port. Listen. Better yet, why not just do it all in one? Why not just do this? You know? Fenrir listen. So listen on port 8472, and then you pass in your callback function. No. Fenrir listen, boom, callback functions. So, what are those functions going to be? So on socket connect. So you're going to want to pass it on socket connect, on socket message, on socket error, and then on socket disconnect. I think that's pretty good, right? Include Fenrir, one line, boom. Listen, hear your callbacks. That's it. No other bullshit, right? That's it. And then you just handle your callbacks. Now, when you say listen, it's gonna just be in a blocking call until it terminates, and then you're done, right? So that's the thing. You don't need to do anything else. Yeah. Because there's no updating going on, right? Yeah, the server just handles stuff as it comes in. Okay, so now if we go over to back to Fenrir, yeah, we go back to Fenrir. So in the Fenrir namespace here we have can I do this? Can I do replace static space with nothing? Yes, I can. Okay. So got this, and then we have a buffer. So this is a function pointer on socket connect. Right. On socket message. Should I do it like this, or should I mean, it's there in the listen, so these are the callback functions, and then here is where we have these on socket connect. It's kind of annoying to have to say it like this. Yeah. I'm gonna have to change this to I don't know if I'm going to do this or I'm just going to pass this to the functions that need them. I probably have to do it like this. But I think I might have a type def of callback. How do I do that again? I think I can just do it with the type def. Socket connect callback. I don't remember how to do. How do I do that? Oh, right, okay. So so that's it. Socket connect callback, and then socket message callback, and then there's socket error callback, and then there's disconnect callback. Yeah. Okay, so socket connect callback, message callback, error callback, disconnect callback. And then so socket connect callback. Connect callback. Socket message callback. Message callback. Socket error callback. Error callback. Socket disconnect callback. Disconnect callback. It was actually shorter to have it there. Error callback, disconnect callback. Right, but at least now we can just say on socket connect is connect callback, and on socket message is message callback, on socket error. So, pass that in. Now we have these available. So we come in here. Let's just make sure everything's still working. What's the problem here? This is already a function I have here, right? I already have a handshake and where's the on-socket data received thing now? Oh, because it's calling, right. I think for this I'd have to do something like that, right? This isn't in any namespace. It's in WinSoft, right? It's not in a namespace. So yeah, on-socket message is a problem because Yeah. What happened to on-socket data? On-socket handshake. So handle the handshake. This should be, so this will be on-socket data. It compiles and runs. And we get our information. Okay, so it's pretty straightforward now, right? Fenrir listen port that we want to listen on, and then these are the callbacks that we have. Okay. So we still need to do the multi-threading stuff, but let's look at what happens. So we don't have a handshake, so on-socket handshake. So on-socket handshake, we do this stuff. And if everything's good, then we wrote the response back. And so if we wrote the response successfully, then we're going to want to call so if on-socket handshake is true, then we have a handshake. So the handshake is now set to true. Handshake is now true. And then we check if on-socket connect. So if we have on-socket connect method, then we're going to invoke that callback. I think I'm gonna have a wrapper around the sockets so that I can pass that in and not have to. Because they're gonna want the sockets as well. I think I tried doing that at one point and then I ran into an issue. So what's the issue? So a socket has a socket, right? So come down here. If we accept a connection, so we have a socket, so great. So we have a socket connection. So we stored the socket in there. No, we don't need anything from the socket. So instead, I should just have a handle, but not the handle. that it has, not the handle that it has. It should be so we should say on socket connect, and we should pass in the handle. So, or maybe the socket ID. Pass in the socket ID, and that's an ID that we keep track of, and so so where are we at now? Okay. Yeah, I think we should have, so we have our buffer, we have our callbacks, right? Just a vector of sockets, right? We just have the sockets. I could make it into a map, but if the socket disconnects, then what do I do? Those sockets still have to be there, so that socket just becomes not cleared essentially. I'll do it as a map for now. It's an unordered map of socket ID to a socket, which itself is a handle. Sockets. So socket ID, a socket ID is just what? I'm just gonna have it as an unsigned int. It doesn't really matter. So socket ID. So on socket connect, we pass in so we need to know the socket's ID. So client connection established. So once we connect, we need to assign a socket ID. Right, if you have a vector, it's easy. If we don't have a vector, then Yeah, maybe I won't have a handle. Well, if it's multi-threaded, how's it gonna work? Oh, it's just waiting to accept calls. Every time it accepts a new connection, it then spawns a new thread, and then that guy's listening for information. That thread. Um, I don't remember the kind of stuff that I need to do with the socket. I might take a break. I'm not sure what I'm gonna be doing with this here, so I might take a break to sort this out. It's just, yeah, I think. So it should be a vector because then I could just get the index. But then the problem is, um, yeah, what kind of stuff do I do with the socket? That's the thing. Like, on packet received, I'm passing in. I created this thing called a client socket, which has the socket itself. Instead of having the socket, and that's so that when you send a packet, I have the socket to do the data. I'm going to do the same thing, but instead this will just be an ID. So I'll say, send this data, and then this is the packet I want you to send it with. This is the socket I want you to send it on, and I just give it an ID, which is just a handle. Now let's say it disconnects and we close everything, we validate that handle. When you come back, that handle would technically still be there. I think it should be an ID that's incremented. I think that's what I'm gonna do. I think I'll have it as an ID that's incremented. So I'll also have a socket ID, next socket ID. And the next socket ID is 1. This is an unsigned integer. Maybe just to be clear, I'll do it as a uint32. Right? It's an unsigned 32-bit integer. Right? So next socket ID is 1. And we'll increment it, right? So the socket ID will just keep getting bigger and bigger and bigger. And then it'll wrap around back to 1. So on socket. So over here, what do we do up here? So up here, once we have a new connection, we need to assign a socket. For that, so we'll say socket ID is equal to next socket ID. So it's equal to the next socket ID. Equal to the next socket ID, and then we check if the next socket ID is equal to, we want to know like if the next socket ID is equal to the maximum value that a socket ID can have, which is this, right? Is that how I should do that? Then if that's the case, then set the next socket ID to wrap back down to 0. I don't know if this is the best way to do this. It's just the problem with the vector is that I'm worried about a case where like a guy disconnects, that socket handle is now available. Yeah, that socket handle is now available, and then like some kind of callback method or a timeout, because I'm going to be doing like timeout methods. So then it's like it comes back and then it tries to do something with a socket that's already been freed. And like if another guy's connected in that time, then the socket will be valid and it will work. But with this, once you free a socket, it's gone, it's out, and then if you try to get that socket, the socket simply won't be there anymore. Which is what I like about this way of doing it. Now, okay, if it wraps around, what if that socket's already in use? Okay, that would be something else, but I could easily check for that. Okay, so the socket ID is the next available socket ID, right? If the next socket ID is the maximum value we can have for a socket ID, then the next socket ID will now be 1. So we just wrap around and then we keep going. If the next socket ID is equal to the maximum, or else we just increment the next socket ID. If it's not, we increment the next socket ID. If it is, then we reset to 1, but then we should also check, is there a socket currently using that ID just in case? And if so, just go to the next one. So socket ID is the next available socket ID, and then we then loop and they loop over all of the current sockets. So grab the next socket ID. So that's the next socket ID we can have. It's really a socket handle, a handle to the socket. Grab the next socket ID and then sockets, right, at this socket ID is going to be equal to this client socket, right? So now we've now got that mapping in there. Then what we do is this thing here where right now we loop through and we say, okay, is the next socket ID equal to the maximum value? If so, go back to 1. Otherwise, increment the next socket ID. And then we check. So is there one of these already in there? So if sockets.find I think actually this is the first time I never use a do loop. So if the socket ID was the maximum value, go back to 1, otherwise increment it. So this is the next available socket ID, but then check, is it actually available? So while sockets.find, so do sockets.finding, while it's equal to sockets.end, sorry, while it's not equal to, right? If it's equal to, if it's not in there, then we break. Otherwise, we keep doing that. So we're going to keep going through until we find a socket ID that isn't already in there. This is way overkill because it's a 32-bit integer, but yeah, it's way overkill, but it guarantees that, and because it's so big, it kind of helps to have these kind of weird edge case scenarios not occur, I guess. Okay, so we have that. Now that we have that, we have our socket ID. So now this is going to be in a different loop and whatnot, but now we do this. So now we have the socket ID. So on socket connect, we now can pass in that socket ID that can be used as a reference later. If we already have a handshake done, then on socket data, and here we pass in the socket. Technically now I could pass in just the socket ID, but so on, well, no, it's easier to do with the socket. So on socket data, so we grab that data. I think I'm not even gonna handle this case, to be honest. When we come in here, we get our message, and what do we do once we get our message? Once we get our message, we then check if on socket message is not null, then on socket message we pass in the socket ID, which socket this came from, and we pass in the message. If it's not null, we call it. If it's null, we don't do anything with it. And if everything works, we return true. Otherwise, if there's an error, then we return false. So, right. Now wait a minute. Why does it need the socket? It doesn't actually need the socket. No, it doesn't actually need the socket. Okay. So what I'm gonna do right now is take a. Okay. No, we don't need the socket. We need the socket ID. So just pass in the socket ID instead. And socket handshake, we need to respond so that we can send the socket. Otherwise, we pass in the socket ID. This will be called by the person using this, so socket send socket message. Send socket message. Socket send, maybe. So socket send. And it will take in a socket ID and then the message. Socket send, it'll do that and then take a message. And I don't think we're gonna have a return or anything like that. If it fails to send, I'm not sure what we're gonna do. Socket send. If something goes wrong, like you tried sending data and something goes wrong, so maybe just like handle that as like a socket error or something like that. I don't know. Okay. Right, I know I need to now specify these in here. So on connect we need to on connect we're gonna need the socket ID. Same here on message. So here it would be the wrong place. You'd have to do Shift P and it would put it there. So if you put it here, P puts it after. If you there, it'd be before this. Okay. So on error, which socket we got the error? On disconnect, which socket disconnected? On connect, which socket connected? And then message callback, we actually get a message. Okay. Okay. Now, let's go to main, and we need to pass this stuff in. Mm. I think socket ID should be out here. Oh, socket send. Right, we need to. So it's this guy here. We need to get the actual socket, right? So what is the actual socket? Sockets.find. Look up the socket by that socket ID. If and okay, and I think what we do is here we say if iterator is not equal to sockets.end, right? So if it's not equal to sockets.end, then this is iterator second, right? Yeah, I'm gonna change this. I'll pass in a struct. I don't want to have it like this. It's a bit too much. I also want to be able to specify the maximum number of sockets. So if you have more than a certain number of sockets connecting, it will it won't accept them. Maybe I will. Maybe I won't do that. So socket ID is just a 32-bit integer. So this is agnostic to the actual type of socket you're using. Yeah. So let's okay, so we run the application, connect to the server. Fuck yeah, man. So this is it. This is the use of the library. It's just that. A couple of callbacks. I think I want to have a struct. Server description. So you'd have, for example, a port, right? Yeah, so server description, or maybe server info. Server description. Server info. Yeah, so Control V, and fuck yeah, man. So I might pass. I might say Fenrir server. So it takes the Fenrir server. Yeah, I don't know. Description. And then instead of this, we'd have server description. Right, and then listen doesn't take this now. Listen just takes a server description. So it takes a server description, and we can just say server description to description. That's a lot easier. So listen, server description. And that gives us that. And then here we can set defaults. So maybe the default port is going to be, I don't know. Yeah, I don't know. Default port, I don't know, maybe 9000 is the default port. I'm not sure. And then these by default will be null. Yeah.
by default, your port will be 9000, and then you won't have any callbacks. Then if we go over to main, we don't have to do this anymore. We say Fenrir server description. And we can set the port to be 8472. On connect. Connect. On message. So you just included Fenrir and then Fenrir server description. So set the port on connect, on message, on error, on disconnect, and then you just say Fenrir listen description server. Server, Fenrir server description, server.port on, right, and listen. Listen, pass in, Fenrir. Yeah, I think this is a nice way of doing it. Server description. Set the port on connect, on message, connect. Listen. Here, listen. And that's it. When it's done, it's done. I think that's good. Fenrir server. Port. Oh. Right, all of these, right? So this is all server description. Okay. Okay, so this is where we're at, right? This is where we're at. Um. Next is multi-threading. We need to do multi-threading. So yeah, I think I'm happy with that. I think I'm happy with that. So, I don't know what the default course should be. 90/90 or something? I don't know. Maybe 80/80. I don't know. Okay, yeah, so the next thing is there's two things really left before I can start using this for my game. The first is, well, three things actually. The first is that I need to figure out how I'm going to handle, JSON objects to C++ structs. The second thing is multi-threading, so I can allow multiple connections at a time. And then the last thing is making this work on Linux, because this isn't going to work on Linux, right? I can't do this on Linux. So making this work on Linux is another big thing. So what we have now, we have the handshake, we send data, we receive data, and now I've actually got it as a library so that it can easily be used. So the basics are there. Next thing should be multi-threading. So let's have multiple threads so that we can accept multiple requests. So, while true, so we should accept, and when we accept, if there's an error, invalid socket, I'm not gonna shut everything down. Failed to accept socket connection. So there was some reason we couldn't accept the socket connection. I think the server's gonna keep going though. Try to accept it. I don't know. Maybe it won't. We get past it. Client connection established. This is going to be more involved now because
This is gonna have to run on a separate thread. And what will that thread need to share? Okay, first of all, let's look at how we're gonna do multi-threading. So to look at that, I'm gonna look at what I was doing in my audio system, because my audio system was using multi-threading. Yeah, so I think it's Process, which is a Microsoft thing. Oh no, maybe not. Maybe not. So, this is a thread, so a bunch of data for that thread. Get available threads, a vector of these threads, a vector of this thread data. So this is where I'm actually creating the thread. Let's start event. So where's this defined? It's in Process. Okay, so it is a Windows thing. Start address, arg list, init flag, thread address. So begin thread, security 0, stack size, it'll just do whatever. Start address, arg list, init flag, thread address, arg list, init flag. So really it's just these two. So where does that thread start? So it's going to start here. It's going to take a void pointer of which is the args, cast it to a sound streaming thread. So now we have that thread data that's on the heap. Yep, this because this thread sound streaming thread is on the heap. And then we do some stuff. So let's do this. So I think I'm gonna have to change the way I do stuff because yeah, I don't think it's gonna be an unordered map now. So okay, so I'm gonna need to have some sort of a queue because we're gonna have our sockets that have this buffer isn't gonna be, the buffer is gonna be per socket. Each socket will have that buffer. So once the socket receives, on each thread, when the socket receives data, it receives that data. It Hmm. So wait for single object. Okay, I think I have, these are kind of locks. So I'm waiting forever for this lock to be unlocked. If it unlocks, then if stop streaming, then just break out. If not, then stream the sound, which does a bunch of stuff. It'll just play the sound, and then once it's done, no longer in use, and then that thread is now ready. So streaming thread. So we have the start event and then buffer event. So you create this thread, and then it's gonna just sit there and wait until you actually say start event, right? I think these are locks, basically. And what's buffer event? So we get an available streaming thread, set all this information, then we reset event, buffer event. I don't remember what that does. Reset event. Create event. This is Microsoft stuff. Create event. Manual reset initial state. Oh, this is where we're actually streaming the sound. I don't really remember what's going on here. But that's how you create a new thread. So we're going to need memory on the heap that's accessible. And what are we going to do? So it's going to be listening for connections. It's going to accept a connection. When it does, we want to put that information on the heap for that particular thread, and then start that thread off, and then we come in and wait for the next one. And we're just going to keep, the application will keep doing that until you close the application. And once you close the application, then and only then will it actually terminate. It'll terminate all the threads, close everything, and free everything.
it's simpler if I just put it in a vector, but yeah, yeah, I think I still want to do that with the socket IDs. But yeah, I think it'll still be a map. But I think what it's going to be now is, well, so we're on a separate thread, and on that thread we're waiting to receive some information. Once we get bytes, it's written into a buffer. So yeah, they each have to have their own buffer. That's for sure. So, so each socket has its own buffer. Right? This thing. And I think socket should also have handshake. Right. Which by default is false. It also has a socket. And then maybe we'll need the socket ID to know which one we are. Okay. Yeah, so it's okay, so this is now a map of a socket ID to a socket pointer. And we come in here, we do all of this. When we accept a connection, okay, we have this. We don't need this handshake thing anymore. But get a socket ID. And then find the next one. So what we now do is we're now going to, so we update the socket ID to which one's the next guy. Client connection established. So client client socket connection established. socket ID is that. Update the next socket ID, and then yeah, this isn't enough. So sockets at that isn't just client socket. It's a new socket. It's a new socket, right? Sockets at this guy. So socket. So the socket ID is socket ID. The socket is client socket. And initially the handshake. Alright, so get the socket ID, create a new socket, set all that stuff up. So we have our socket ID. We'll have a new buffer. Initially handshake will be false. So we have this, and now that we have this, we can now, what we'll do is just start a new thread with this socket. Should this thread be called? I'm not sure. And what is that thread going to do? It's going to do this. So and it has to match this signature, right? It has to match this, so it has to be a say unsigned int st call socket thread takes args so this is the sockets thread, and we need to get the actual socket. So the socket is, we're just going to say sockets dot find. We'll pass in, or no. So reinterpret cast to a socket pointer. Yep. Socket thread. And now if we go to here, we can actually start that thread. So okay. So we're gonna have a okay. Reinterpret cast to a handle. So begin thread ex socket thread is the function we're gonna call. As an argument, we're gonna pass in the socket, and then we have that. Now, so now we're listening. We accept the connection. If there's a problem with the connection, I don't know what we should do. If it fails, we could keep going, or we could just shut down the server. I don't know what we'll do. So, client socket connection established. And then we just come here, we loop back. Begin thread. We need to keep track of that. We need to keep a handle on that thread. So right, okay. So we need to get well, it's easy. We can just iterate over the socket. So we can say socket thread. This is that, right? It's the thread handle. So if we go here, socket ID, the buffer, handshake, the socket. It's gonna do this. So that will start a thread. This, right? We get our socket, and then we just do a while loop, and we need to return something here. So we return 0. I think it's good. Return 0. Yeah. So what's the socket? The socket is socket. The buffer is socket buffer, right? We're gonna read into this buffer. I'm gonna get rid of the error thing. So on socket data, Once we get data, we then call onSocket data with the number of byte. We need to pass in the socket is what we need to do. OnSocket data, we need to pass in the socket itself. You just pass a reference to that socket. Yes, we can pass a reference to the socket. If we have a handshake, then it's that. If we don't have a handshake, then we say onSocket handshake. And again, we want to pass in the socket. But we do need to know how much data was sent in. Right, socket, how many bytes? Shit. Should be socket. Socket send. Okay. So onSocket handshake. So we do this, and then all of this is to change. Fuck, all of this has to change. OnSocket handshake. So the socket, number of bytes, read line from buffer, we need to pass in that buffer. So it should be the buffer, the number of bytes, right? Read line from buffer, again, should be the socket's buffer. Read line from buffer, it should take a char. Why not just pass in the socket, and then you can just say socket.buffer. read line from buffer. They both use that. Okay. On socket data, this is different. On socket. I don't think I'm going to handle this case. I think we should get rid of this. We're not going to handle this much data. Extended payload not supported. I can do this, do that, Shift I, socket dot, boom. Send socket. So you call send socket. So we're going to need to have a queue of things that we're doing. We're only going to do one thing at a time. So we've got our thread that accepts a request and then spawns other threads with those sockets. And then that thread is waiting for data. Once it gets data, right, it does this processing, reads it, and either calls on connect or on either calls on message or on connect. But the problem is that if you have two sockets that receive data at the same time, they should be whoever got there first should be handled first. So when you get these messages have to be handled one at a time. So we need to have another thread, I think. It's just too bad that yeah, it's just too bad that we can't asynchronously, like, accept will just wait there forever, right? It's too bad we can't it's too bad we can't check to see if there's an exception, accepting. If we are, then we do all of this. And then if there is nothing accepted, then we go through a queue of messages and stuff. So I may rename this from Fenrir to WebSocket. I might. Okay, we're gonna have to spawn. I haven't worked with threads for a long time. The only time I did it was really when I was doing the audio for this for my game. So yeah. I think we need to create a new thread, and that thread so this new thread I'll call it event thread. So we'll do the same thing. So event thread handle. Socket has a thread handle. So we start this thread. We start this thread. So we start a new thread. This goes off on its other own thread, and this thread this thread will have this thread event thread. It will handle the events. So whenever you have an event, instead of saying like we're doing right now, instead of saying just calling that onConnect method for that particular socket, so yeah, so what we will do now is we got this information. Okay. We've responded to that socket with the handshake. And now we're gonna call onConnect. So that has to go into a queue. Hold up. So we have to basically, before we can do anything, we have to wait to just realized, like, if while it's waiting, it might receive more bytes, right? So we might have bytes from the next. No, that should be okay. I think it'll be okay. So what we want to do is we basically want to lock until something's available. So how do these locks work again? I do these create event. This is familiar, but I forget exactly what it is. Creates or open a named or unnamed event object. It's signaled or non-signaled. So here we have start event, and it's not signaled, it's false. And it has access to that so that we can then set the event, right? We set the event. And then we wait for a single object for an infinite amount of time. Okay. All right. So instead, what we would do here is we would say while so okay, what we would do, I think, is we have a function here. Add event to or in-queue event, and it's just gonna be yeah. 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 So it's an event. I think it's just a queue, right? First in, first out. Queue. And then I'll just call it an event. And then we need to know which socket this event is from. And then I'll put the message in there. So there's different events. There's a connect, message, error, and disconnect. Those are the event types. So the event has a type, a socket, and then a and then we're gonna have a queue. I believe that's the way to do it. So we're gonna have queue of events. Event queue. So in queue event, so you have to wait before it's available. So while, so wait for single object. We're waiting for a particular event to be signaled. Here's the thing though. Damn. Yeah. Damn. This is not that simple because I think, okay, so that event, this is gonna be for any socket, so like this socket has to wait until it, basically we need a lock. Multiple people are writing to this thing and we need a lock. We need a way of locking it so that multiple people can't write at the same time. This is gonna be more involved. Thought. Well, I thought there was a way to do simple locks. So they have STD threads. What about in, how does that work? These aren't P threads, but I'm not using that though. I'm using this. Begin thread. Yeah, maybe I'm doing it the old way, but unsigned. Hmm. It can wait for a semaphore. Creates or opens a named or unnamed semaphore. I forget all this stuff. Haven't worked with threads for a long time. Use a queue or a set. Remember. Expect a shared resource from simultaneous access by multiple threads. Each thread must wait for ownership. What I want to know is it first to call the acquired will get it once it unlocks? That's what I need to know. So is wait for single object first serve. Out of your control. So undefined behavior is an appropriate way to describe it. Fuck. It is in practice it's first in first out, but it's not guaranteed. Okay. The mutex object is mostly fair. Okay, I think I'm gonna call it, and yeah, I have to get back to multi-threading next time. Yeah,